Welcome back. Last time we talked about and also showed something about an end-to-end analytics platform without a bogus licensing, expensive licensing like the kind of Silicon Valley licensing for dashboarding tools. We even talk about the visualization platform without licensing, that is the Apache Superset. Yeah. Now, we want to show you this time around a kind of a use case, an actual business problem that benefited from this end-to-end solution. Yes, the data that was engineered and the analytics was realized using um, a platform without licensing. Now, what was the challenge of this business entity? Okay, um, the business entity is a kind of involved in logistics. They have an ecosystem of a supply chain ecosystem made up of third parties of distributors. And you will agree with me, in that kind of ecosystem, you are going to have data from disparate sources, fragmented all over their applications, because each of these distributors are independent. So you're going to have data from ERP, you have data from you have CSV files, you have some touch points for data, the APIs where you need to get some data from some distributors. So this is quite chaotic, and the business had a hard time preparing um, data from these sources, and that often results in inconsistent KPI calculations. And again, running queries against these different channels creates a lot of performance overhead for the dashboard. So this was the scenario. This was the business problem, the business scenario that needed to be solved. Now, what I did was to come up with this full stack analytics platform end to end, from ETL to visualization, without necessarily paying licenses for this Silicon Valley type of visualization platform. Now, this the ETL I created helps to transform this data from these sources into analytics ready data set, and immediately the data set is ready, then we could use Power BI to create the dashboard for the enterprise users as per the business requirement. But however, the business want to save some costs by using the Apache Superset without license for the distributor. So there is no need to buy extra licenses for distributors if they can buy a few licenses for Power BI for the internal user. So that is actually the winning point for the business, their desired winning point, so to speak. So how they can save cost, exposing the same data that they have in Power BI to their distributor, but using a platform that doesn't necessarily require licenses. Now, between this challenge and the solutions, so the ETL was constructed, using a bit of Python and then SQL to combine, to kind of embed SQL inside Python. Python has um, a feature that helps to actualize it. That is called the SQL Academy. So that was what was done. So that's the general overview of how the solution came about. Now let's go deep dive into how this was achieved. Now the first one was the ETL pipeline. So that is the extract and the load phase. Now what was done was that the extraction was done using Python and SQL. Now, the SQL was used to create the select statement and other related statement to be able to extract the data. Now, this SQL statement was embedded. I embedded it inside the Python scripts such that when you run the Python script, automatically run the query against the database. Now let me explain how that was done. I'll show you the Python file. Just give me now. This is the Python file. Now with this Python file, I'm able to connect to the database direct. Now this is the SQL I talked about, so you can see it was embedded inside the Python script. So once you embed into the Python script, so the table is automatically created, and after the selection, it is loaded into the database automatically. Now, at the end of the day, you have a table that is created, which are called finance all the finance table, so to speak. Now, this was the initial approach just before the IAT, the internal acceptance test. But if you check here, you discover that I did something different here. That is a kind of an add-on, so to speak. Now, instead of having that Python file, which if will need to be recreated if I have another client that need the same kind of solution. So I decided to create a reusable solution by creating a Python package. Now, this Python package, we have the Python script and then the combination of the SQL script. Then I now make it a package such that that package becomes reusable. So in other words, whatever kind of data you want to actually use in this ETL pipeline, extract and load, you could just plug in into the Python package without necessarily creating several files. So this was actually to make it smarter. So I created a package. If I show you my VS Code, you see where I did the package. Just hold on. I think my VS Code was down. Let me see. Okay, that's my VS Code rather. Now, if you check the VS Code here, you will discover that this is the Python package. It's called PKG DB data to DB. That's the name of the package. And inside this package, you have several modules and with embedded functions. For example, you can see the DB extractor, where you can connect to Presto to MariaDB. If you want to optimize the table, it has a function for that. So all the functions necessary to create the pipelines are right here. So you have another module here where I can create a table. If it doesn't already, then load data into the table. So it's actually a kind of a package that you can actually move from one project to the other without necessarily creating a headache. So that is why here you see that I added this Python package, extract and load. So it makes it smarter and easier. And of course, the data validation and quality checks in terms of to ensure completeness and accuracy of the data were also embedded in those scripts. So you just have only one script in the Python package, which makes it smarter. So that's what I did, and that makes it reusable. Now, after the extract and load, you will agree with me that there may be a need for transformation because you are doing an analytic solution. So the table may come like a transaction table, so to speak. So you need to normalize the data. So that's what I did. I kind of clean the data, normalize it. And because of normalization, I try to create a star schema because if you want to do analytics for most of all these sales and financial reporting, you would prefer a kind of a structure where you have the dimension tables and the fact table connected properly. So using what we call the star schema. So I transformed the data that was loaded initially into a star schema so that I can be able to do some reporting, some profitability aggregation on that particular table. Now, for that table to also be smart, what I did was to optimize it by adding indexes where necessary, so that if you want to spool data from the table, it will be smart. And even partitions, so some partitions across maybe year. If you have a couple of years on that particular table, I did some partitions so that the access to that table or select from that table will be smarter. Now, if to explain it further, just like I did in terms of the load, the extract and load, in terms of the transform, I think I also created a package. Yes, I actually did a package. Now, if you check the package I mentioned in my VS Code, you discover that I have added what we call load and remoder, load underscore remoder. Now, this query is what I use to generate the data from the system in terms of creating the star schema. You can see that it's now embedded in this code. Now, let me explain this star schema, because I've been talking about star schema. Now, in reporting for a financial kind of financial reporting, you need to you have what we call the base data. Now, let me go to my dbeaver. Maybe that's where I can explain it better. If you look at my dbeaver, which is my SQL ID, so to speak. Now, what I did here was to get the base data from the data that I extracted from the source. Then after getting the base data, I create a KPI out of it and make it a kind of a star schema based KPI table. Now, what I did for the base data, I repeated it for the derived. In financial reporting, there are some KPIs that are derived, like all these profitability KPIs. You want to measure gross profit, net profit margin, and some other derived KPIs. So I did the same thing for this. Then at the end of the day, I have two tables or views. One is for the base KPI, which you are seeing here, and the other one is the derived KPI. So now I consolidated these two into one financial all KPI table. Yes. So that single table now serve as a source for any dashboarding tool that I needed to use, either a Power BI or Apache Superset or whatever. So in that case, if you see my um, um, my package, you will see that this script that you saw in the beaver just now is now embedded in extractions. So yes, it's embedded in extractions. So that once I run this package and the function therein, the system will automatically extract, load, and transform, and then come up with a table called financial or KPIs. So that's how it was done. So at the end of the day, I have one single report, one single table that serves as a source for the rest. So now this is what I tried to interpret here. So it was converted into a package, which makes it easier for us to use. Now, another thing, at the end of the day, now you don't want to use it as a source for any analytics tool. You can see the first one I did here was to connect Power BI to this Microsoft, MySQL rather. Do the connection, and then here they create a dashboard. Now let me show you the Power BI interface. I think I have it right here. So where that was actually done. Hope it comes up. Now, yes, this is the Power BI interface. So you will see that the dashboard is ready, but before that, you will see the data source where it was used. You can see the financial, the executive overview of the trends. Then you have the income analysis. You have the financial performance analysis. Then you have the financial position. So just exactly as the client wants its report in Power BI made for external users. Now there's something I want us to take note here. If you check the data source here, whereas I mentioned an all-in-one KPIs table, But you can see you are seeing something like financial KPI time matrix. Now, uh, yes, the only one KPI would work, and then I can create all these time series values, maybe using DAS, but to actually facilitate a faster and smarter dashboard, I prefer to actually calculate those time series right on my script. So let me go back to my deliver. Okay, if you check here, you will see this is the table that I mentioned, but now this is the table you are seeing in Power BI. Why? Because I have added time series calculations to the table. Now, what do I mean? Let me show you a bit of it here. Now, this is the actual table that came, the star schema table. Sorry, the star schema table was actually, I think it's called the all the all-in-one financials. But now, yes, look at it here. Look at it. This is the financial all KPIs. Now, I decided to create financial time series KPI because I wanted to all these times derived values that are time series in nature. I have to calculate them right in my script. You can see each of them. You can see something like the gross profit, the the percentage of one month over the other, a kind of month on month, year on year, and stuff like that. You can see even for quarter on quarter, they are calculated there. Even the rolling values in terms of rolling 3 months, rolling 12 months, everything is calculated here. So if you check the table, the resultant table, you will see something like ARO days, cash investing, the cash ratio. So these are automatically calculated right with the SQL script instead of going to the dashboarding tool to be writing DAX and trying to create metrics in Apache Superset. It's not that it won't work, it works, but it creates some overhead for the dashboarding tool. So that is why I did it this way. And at the end of the day, I now came up with a final table called financial time metrics. So this is what you are seeing in the Power BI right here, financial KPI time metrics. You can see that the feeds, you will see something like month on month, month to date, quantity, quarter to date, year to date, and stuff like that. So with this kind of approach, so my dashboard are smarter and faster than trying to use these formulas within the Power BI itself. So the platform is fetching the data direct. You can see how smart the dashboard is because it's picking data direct from one source because it's already pre-aggregated. It's a kind of a smart cube that is now serving as a source for the data. So this was how the Power BI was done, and then the internal users were happy because their dashboard is fast and responsive. Now that's the Power BI. Now the next thing is the other need of the business, which is a pain point that okay, we don't want to buy licenses for Power BI license for our distributors, but we want a separate platform that is zero license, and that was where the Power BI came into the picture. Now this is the Power BI. This is Apache Spark came into the picture. Now if you check here, you discover that here I actually set up the Superset environment to connect to my SQL database. Then with that one, I'm able to I deploy the Apache Superset to their environment. Now you see the dashboard, the same kind of dashboard that you see in Power BI are also shown, but the only difference here is that the data access in terms of security, if a distributor logs in, he only gain access to his own particular data in question, unlike the internal users who could review several partners. He views only his own data. Now let me go to the Superset where you see exactly how it was done. Now if you look at, this is where you have the Superset. Let me go to the dashboard area. Now this was the financial analysis that was done. You can see the income statement right here. You can see the income statement. You can see revenue, expense versus gross profit. You can see financial performance analysis. You also see the financial position, just like you saw in the Power BI. Same data, same feel and look, just different tool. One is heavily licensed, the other one is zero license, which save cost for the business. And then you also have the expense analysis as well on that Superset platform. So it was smarter and easier for the business, and it was also a cost saving for them. So this was how the solution was deployed. So they got their data ready both for internal users and for the external user, which are the distributors. So in a nutshell, if you look at this package solution, this smart analytics platform just delivered, the technical competencies that came to play here was one, uh, Python. Python definitely was very key in this delivery, which is SQL Academy, SQL Academy benefit that is used to interact with database, and of course the native SQL of MySQL was also there, although it was embedded in Python. Then of course now have the Power BI, where the analytics was dashboard was built for the internal users, and of course you have the beautiful bride, the Apache Superset, that is zero license compared to Power BI, which saved the business cost, and that was used to create dashboard for the business. So it was a win-win. The smart solution was delivered, and the business is happy because they are able to save cost and minimize licensing cost, so which help them with improve their operational efficiency, so to say. So if you admire this kind of a solution and you want to know more, you want to see if it is something you can do, either a full-blown full stack, or you want to do a hybrid of it, maybe ETL using one of the big tools, then use visualization as your superset, or you want to do ETL, a custom ETL, and then combine Power BI and Apache Superset as your visualization tool, or you just want Apache Superset all the way, we are here to support you. So you can contact us via email, douglas.inegwedio@infotechplanning.com, or via WhatsApp with that number right there. And you can actually look at our blog site, infotechplanning.com, and you get more details. So, thank you. Thank you.